If you're coming from the JavaScript world, diving into TypeScript can look a little scary at first. But what if I told you that the most common types, the ones you'll use every single day, are really just a small step up from the JavaScript you already know and love? Today, we're going to pull back the curtain on TypeScript's core types and see how they can solve some of JavaScript's biggest headaches and just make your code so much more solid.
Oh, you know this one. We have all been there. You're coding away. Everything looks perfect. You run it and bam, crash. This classic error is really a symptom of JavaScript's greatest strength, which can also be its greatest weakness, its incredible flexibility.
You know, JavaScript is happy to let you pass anything, anywhere. And that is awesome for getting things up and running quickly. But when your app gets bigger, that same freedom can lead to some really sneaky bugs. The kind you don't find until your users do. That's where TypeScript comes in. It's like a safety net that helps you describe what your data is supposed to look like, catching those errors before your code even runs.
All right, so here's the game plan. We're going to start with the absolute basics, the stuff that'll feel really familiar. Then we'll build on that to describe more complex data. After that, we'll see how to make our types reusable, how to give TypeScript a little nudge when we know better, and finally, bring it all home to see how this lets us code with a whole new level of confidence.
So let's start on some familiar ground, okay? If you know JavaScript's primitive types, and you definitely do, then you're honestly 90% of the way to understanding TypeScript's basic types. It's that close. First up, the string. No surprises here. It represents text, just like you'd expect. The only new piece of the puzzle is this little bit of syntax, a colon followed by the word string. That's called a type annotation. Simple enough, right?
Next, we've got number. Now, some other languages make you worry about integers versus decimals, floats, and all that, but TypeScript keeps it really simple. Just like in JavaScript, any number, whether it's a whole number like 42 or a decimal like 3.14, it's just a number. Easy.
And rounding out our core trio is the boolean for your classic true and false values. And just like that, you now know the three most common, most fundamental types you are going to be using all day, every day in TypeScript. Okay, so primitives are great, but let's be real, most of our data is way more interesting than that. So let's see how we can use these simple building blocks to describe more complex things, like arrays and objects.
Typing arrays is one of those things that just makes sense. All you do is take the type of whatever's inside the array, let's say number, and you just stick a pair of square brackets on the end. And that's it. Number squared literally just means an array of numbers.
Now for objects, you basically get to define their shape. You just draw an outline. You list out the properties the object should have and what types they are, all inside curly braces. This tells TypeScript exactly what to expect. An object that has an X, that's a number, and a Y, that's a number.
But what about properties that might not be there? I mean, that happens all the time in JavaScript, right? Well, it's super easy. You just add a little question mark right before the colon. This tells TypeScript, hey, this last property, it might be a string, or it might not be there at all. So don't freak out if it's missing. Okay, this next one is one of TypeScript's absolute superpowers, the union type. By using this pipe symbol, that vertical line, you can say that a variable can be one of a few different types. Here, we're saying an ID can be a string or a number. This is so powerful because it lets you describe your data just like it is in the real world. So if you have a variable that could be a string or a number, how do you work with it? Well, this is where TypeScript gets really, really smart. If you do a simple JavaScript check, like type of ID equals string, TypeScript understands that logic. Inside that if block, it knows ID has to be a string. This is called narrowing, and it's like TypeScript is a detective figuring out the type based on the clues in your code. So writing out these object shapes over and over again can get pretty old pretty fast. Not to mention it's easy to make a mistake. So let's look at how we can give these custom shapes a name so we can reuse them all over our code. So there are two main ways to name an object type, a type alias and an interface. And as you can see for a simple object shape like this, they look almost identical. So you're probably asking yourself, okay, what's the deal? What's the difference? And here's where we see the real difference. The biggest one to remember is that an interface is open, meaning you can add new properties to it later on. A type alias, on the other hand, is closed. Once you create it, it can't be changed. A good rule of thumb, start with an interface for your objects. If you find you need something an interface can't do, like naming it union type, then switch to a type alias.
Look, TypeScript is incredibly smart, but it's not a mind reader. There are times when you, the developer, just know more about a value's type than TypeScript can figure out on its own. And in those moments, you can give it a little hint.
This is so cool. Instead of saying a variable is just any string, you can use literal types to say it can only be one of a few specific strings. So here, alignment can't be top or bottom. It has to be left, right, or center. This is amazing for preventing typos and making your code basically self-documenting.
A type assertion is basically you looking at the compiler and saying, hey, trust me, I know what I'm doing here. When you do a getElementById, TypeScript just knows it gets back some kind of HTML element. By using asHTMLCanvas you're telling it, I know for a fact this is a canvas element. Just remember, this is a message to the compiler. It doesn't change your code when it runs, so you'd better be right.
Okay, we've gone through a lot. Primitives, complex objects, reusable types, even giving TypeScript hints. So, what's the point? Why go through all this trouble? What's the real payoff?
Well, the benefits are huge. You start catching silly typos and bugs right in your editor, not when your app is crashing in front of a user. Your code starts to document itself. The types tell the story of your data. Your editor's autocomplete suddenly feels like a superpower. And maybe the biggest thing of all, you gain this incredible confidence to change and refactor your code without being afraid that you're breaking something somewhere else. It's truly about moving from chaos to clarity.
And this quote just hits the nail on the head. It's not about making JavaScript harder or adding a bunch of rules. It's about empowering you, enhancing the language you already know, and making you a more effective, more confident developer. So, I'll leave you with this to think about. Take a look at a project you are working on. What's the first thing, a function parameter, an object you use a lot, maybe a simple variable, that could be made a little bit safer, a little bit clearer with just one simple type? Because that's where the journey from JavaScript chaos to TypeScript confidence begins.